Alright, ghosts. A May 2000 Gallup poll found that 38% of a random sample of 1,012 adults said they believe in ghosts. Find the margin of error for this poll if we want 90% confident in our estimate. Okay, so remember here that for our confidence interval formula, we have p hat plus or minus z times the square root of p hat q hat over n, and that's all under there. Got it? Alright, so this right here, this piece right here is called standard error because we use p hat and q hat. We wouldn't call that standard deviation unless we use p and q. And this z times p hat q hat over n, the square root of that, this whole thing right here, that's called margin of error. So we got to find that margin of error. So for a 95% confidence interval, z equals 1.96. For a 90% confidence interval, z equals 1.645. So we're dealing with a 90% confidence interval here, right? So we're going to do margin of error equals 1.645 times the square root of p hat q hat over n. And if you do that, you get about 0.025, which is about 2.5%. Okay. B says explain what the margin of error means. Well, again, remember that p hat here is, let me just write it over here. The confidence interval equals p hat plus or minus margin of error, which is z times the square root of p hat q hat over n, right? Well, our q hat here is 0.38 and our margin of error is 0.025. So the margin of error means that the pollsters are 90% confident that the true proportion of adults who believe in ghosts is plus or minus 2.5% of the estimated 38%. Okay, so this 2.5% is, we believe, is 2.5% less than. So our confidence interval would be 0.355 to 0.405. So we're 90% confident that between 35.5% to 40.5% of people believe in ghosts. Okay. And then in C, if we want to be 99% confident, we got to find the margin of error. Okay, well, how do we do 99% confidence? Well, we shade in 99% in the middle. So what does that leave? Well, that leaves 0.5% here. Okay, and 0.5% there. So if I'm going from left to right, where is this? Well, that's at the 0.5% mark. And where is this? This is at the 99.5% mark. So in order to find that z-score, I gotta go to my calculator and I say, okay, calculator, we're gonna do inverse norm of either 0.005 or we can do 0.995. Okay, you get the same thing, one's positive, one's negative. So in order to do that one, what's our margin of error going to equal? Well, margin of error equals z times square root of p hat q hat over n. Well, what's z now? Well, z is 2.58, right? Or 2.576. So 2.576 times the square root of 0.38 times 0.62 times 1,012, and you get like 0.039 or 3.9%. So it's going to be wider. Well, we're more confident, so it's going to have a bigger interval. We're less precise though. Okay. And then question E says, in general, if all other aspects of the situation remain the same, will small margin of errors involve greater or less confidence? Okay, well, if you have a smaller margin of error, that means you're trying to nail down P, then you're going to be less confident. Okay, This is a 90% confidence interval, that's our margin of error. This is a 99% confidence interval, that's our margin of error. Okay? We're less confident, smaller margin of error. More confident, larger margin of error. And that's basically driven because the z-score and the larger margin of error got bigger. It went from a 90% of 1.645 to a 99% of 2.576.